Okay, so this is 7.5, I believe, part 3, I hope. We're on example 6. Kind of lost touch of my parts here, what I'm doing here. Okay, so here are your two tangent identities. And again, you have alpha and beta. So see how these can get a little ugly. We've got just 2 examples to do here. So again, you don't have to memorize them. I would have given them to you anyway. But you have to know where to find them. That's the important thing. So here we go. Use the sum and difference formulas to establish this identity. So we're going to find the exact value of the tangent of 2 pi minus theta. And again, this is my alpha, this is my beta. And I'm going to use this identity here. So it would be the tangent of 2 pi minus the tangent of theta over 1 plus the tangent of 2 pi times the tangent of theta. Well, let's figure that out. What's the tangent of 2 pi? Well, it's the same thing as the tangent of 0, which is 0, minus tangent theta, all over 1 plus 0 times tangent theta. So that's negative tan theta over 1, which is obviously just negative tan theta. So we've simplified that. Okay, let's look at this example. Now, I'm going to tell you that if you look at examples similar to this in the book, they're going to show you 2 different methods. I've tried both methods. In my opinion, this is going to be the easiest one of the methods. You're going to have maybe one in your homework, so we're going to do it. But I truly believe this is the easiest method. They do like a substitution thing with the second method, and it's just too complicated. So what we're going to do, if we're going to solve this equation, is we are first going to square both sides. If I square this, now remember I have to FOIL it out, it's going to be sine theta, or sine squared theta, minus 2 sine theta cosine theta plus cosine squared theta is equal to, and if I square negative root 2, I'm simply going to get 2. Well, look, here I have a sine squared theta plus cosine squared theta. What is sine squared theta plus cosine squared theta equal to? It's simply equal to 1. So I made a substitution of 1 in there. Let's subtract the 1. And let's divide by negative 2. Okay, now from here, and this is the part that's going to get a little tricky. You just have to really think about it. So first of all, if I want to multiply a sine theta times a cosine theta, and I want to get a negative number, that can only happen when the sine and the cosine are different signs. In the first quadrant, they're both positive. In the third quadrant, they are both negative. So I'm looking for a second and a fourth quadrant angle. So that's one thing I'm going to say. Okay. So I hope you can also see that if I am multiplying a sine and a cosine, I'm not going to be finding things, I can't multiply like root 3 over 2. Anything that deals with root 3 over 2, I'm not going to end up getting negative 1/2 as an answer. Because remember, all I'm doing is I'm looking for an angle that when I multiply its sine and its cosine, I'm going to get negative 1/2. I hope you can see that the only way that that can happen is if they are multiples of 45 degrees, or 45 degrees is the angle that we're looking for. Because I can multiply root 2 over 2 and root 2 over 2. Think about it. Root 2 over 2 times root 2 over 2 would be 2 over 4, which would be 1/2. So those are the values that I'm looking for. So what is the second quadrant angle where that is true? Well, the second quadrant angle would be 3 pi over 4. And let's just quickly check it. So what is the cosine, or the sine of 3 pi over 4 is root 2 over 2. And the cosine of 3 pi over 4 is negative root 2 over 2. If I multiply those, I'm going to get negative 1/2. And the fourth quadrant angle where that is possible is 7 pi over 4. So again, that type of problem doesn't happen very often, but I just think the other way they showed you is much too complicated. This makes more sense, in my humble opinion. All right, so there is the end of 7.5.